Hey guys, welcome back. In the last lecture, not in the last lecture, in module 2, we set up our connection to Olama. We wrote the ask function, if you remember, the function that sends prompts to our local LLM. We tested it and it worked. Now we will use it here. Just copy it from there and use it here. In this lecture, we are going to extract headings from a document using Olama, and for that we will use ask function. We have a sample document with chapters and sections, and we are going to use Olama to read that document and identify all the headings with their correct levels. By the end of this lecture, you will see output like this. Extracted headings. Level 1 is chapter 1, level 2 is 1.1, and level 2 again is 1.2. But first, we need a document to work with. So let's go ahead and create one. So sample doc equals, now print sample document created. Print sample doc. Let me walk you through what's happening here. We create a variable called sample doc. It holds a multi-line string that is our test document, and then we print it so you can see exactly what we are working with. Now notice the structure. We have chapter 1 and chapter 2. Those are the top level. Inside each chapter, we have subsections like 1.1 and 1.2. And inside one of those subsections, we have even deeper levels like 2.2.1 and 2.2.2. Three levels nested inside each other. That's the structure we want to build. That's the structure we want Olama to understand and extract. Now we need to tell Olama what we want, and we do that by using building a prompt. So we create a prompt. At first, we define a function called build extraction prompt. It takes one argument, document text. Inside, we create a variable called prompt. The F before the quotes makes it an F string, which means we can insert document text directly into the prompt. The prompt starts with an instruction. Extract all section headings from this document. Then we list the rules. Level 1 is the main chapters. Level 2 is the subsections. And level 3 is the subsection. Now here's the important part. We tell LLM to return only valid JSON, and we show it the exact format we want. Then we insert the document text. Notice slicing to 2000. That limits it to 2000 characters. This saves time and saves token. And finally, we repeat the instruction. Return only the JSON array, nothing else. We say it twice because LLM sometimes need reminding. Now here's where it gets interesting. We build the prompt, we send it to Olama, but here's the thing. Even though we said nothing else, the LLM often adds extra text. It might respond something like this. Here are the headings you requested. The headings, and then, I hope this helps. Let me know if you need anything else. Now in this case, it's returning perfect answer. So we tweak the prompt a little to get a faulty answer, because sometimes some LLM returns an additional note along with the answer. So let's change it and run this cell. Perfect. Now we get this extra piece of note. This is what I call the love note. The LLM is trying to be nice. It's being polite, but it's breaking our code because JSON.loads cannot pass here are the headings plus brackets. It only understands pure JSON. The moment there is an extra text, it crashes. So we need a solution, and for solution we need a clear response. We need to pull out just the JSON and throw away everything else. So we are going to use a regular expression to do that. Now let me show you the key line first. RE search R slash bracket. Now everything inside the bracket slash again of bracket and response comma re.all. Now I know that looks a little scary. Let me break it down for you piece by piece. re.search. This is a function that searches through text. It returns the first match it finds. R is a raw string. It tells Python don't interpret backslashes especially. Slash square bracket, opening square bracket, it means find an opening square bracket. The backslash is there because square bracket has a special meaning in regex. So we escape it to say I mean a literal bracket. Dot star means match any character 0 or more times. And finally re.all. It's a flag. By default, dot doesn't match new line. This flag says match everything including the new line. So the whole pattern is saying find me everything from an opening square bracket to a closing square bracket including all the new lines in between. Now let's see what match looks like when we print it. Print match. You get something like this. RE match object span 56. So we don't want that. We want the actual text that was matched. So we call match.group. Now we print match.group and now we get this. It's beautiful. The love note is gone, but we have one problem. Match.group returns a string and a string is not helpful. We want a list of dictionaries so we can actually navigate through it. So we pass it through JSON.loads. JSON.loads match group. And now we have a proper Python list. Each heading is a dictionary with a level and a title. Exactly what we needed. Now let's wrap all of this into a clean function. So we write def extract JSON from response and we pass a response. We copy paste everything. So we pass a raw response from Olama. We search for JSON using our regular expression. If we find a match, we print the first 100 characters just to see if it worked, and then we convert it and return a proper Python list. If you find nothing, we print no JSON found and returns an empty list. We will run this and we get the answer. Now we'll copy this function, paste it here, and we will call the ask function here. And now call the extract from JSON, pass in the response, and we will return it. And now we will run it. Sample doc. Now we will print heading. Perfect, we got the perfect heading. Now in the next lecture we will learn how to build trees.